Welcome to our video on proportions. A proportion is an equation which states that two ratios are equivalent. And there's two different ways we can solve proportions. We can solve proportions by using cross products. That tends to be the favorite way of solving. And when we use cross products, our solutions or our cross products will be equal. Or we can use the least common denominator like you would use in an equation with fractions. Let's look at some basic examples. So we have two ratios, 12 to 15 and x over 55, and we want to know what the value of x will be to make those two equal or equivalent. So let's use cross products here. 12 times 55 and 15 times x gives me 660 equals 15x, and then by dividing both sides by 15, I get x is 44. So 44 substituted in for x would make those two fractions equivalent, or those two ratios equivalent. For this next example, I'm going to use the least common denominator. You can definitely use cross products, but I just want to give you an example of least common denominator. So 4 and 6, least common denominator is 12. So multiply both by 12. 12 times y is 12y, divided by 4 is 3, so we get 3y equals 12 times 5 is 60, divided by 6 is 10. So 3y equals 10. And then we divide both sides by 3 and get 10/3, or 3.3 repeated. The third one, I'm going to go back to cross products. This is the preferred way, my preferred way, but you're welcome to use either. So we're going to do 13 times 4 and 5 times z. We get 52 equals 5z. So z is 52 fifths, or 10.4. Now it's your turn. Solve for the variable. Pause the video, try these, and then check your work. Hopefully your answers match mine. First one, we get a is 9. I did use least common denominator, but you could have used cross products. B, we get 42/17, which is approximately, that's what that squiggly line looks like. It means approximately 2.47, or 2 47/100. And on the last one, we get C is approximately 41/100. Or if you left it as a simplified fraction, 205 over 506. Both answers would be acceptable. When we have proportions now with a variable in the denominator, we need to use cross products. We don't have the skills yet to be able to do this by using least common denominator. So in these two examples, you're going to see I use cross products. And although they may look very confusing, with our understanding of distributing, we'll be just fine. So the first example, 6 times 24 and d times 21. This one is pretty straightforward, just like the other ones. We get 144 equals 21d. So d is 144 over 21, or 48/7, which is approximately 6 86/100. Now the second one looks a little more confusing, but if we take it step by step, we're going to come up with an answer. So cross products, 3 times x, that's pretty basic, and then 2x plus 5 times 7. Now we put the 2x plus 5 in parentheses to remind us that that is one value. We don't want to split that up. So 3 times x is 3x. And then to use the second piece, we need to use a distributive property. So 7 times 2x is 14x, and 7 times 5 is 35. Move variables to the same side. Now notice I move the 14 to the 3x because I know I need to have it opposite my constant. I get negative 11x is 35, and x equals negative 11/35, which is approximately 0 31/100. Your turn. Try these two, pause the video, and then come back and check your work. Hopefully your work matches mine. Again, using cross products on number 1, we get 20 times 5m. And then the quantity of 2m plus 50 times 5. 20 times 5m is 100m, and then we use the distributive property. 2 times 5 is 10m, and 5 times 50 is 250. Notice I solved and simplified and got m is approximately 250 over 90, or 25 over 9. which is equal to 2.7 repeated, or 2 and 7/10 repeated. 2, again, cross products, and we're solving for g. So 2g plus 8 equals times 5 equals 3g minus 1 times 4. Distribute, cancel that constant and cancel the coefficient, and we end up with g being 22. If you have questions on these, just bring them to class and I'll be happy to go over them. Finally, we always have to talk about applications, word problems. And proportions are used very often in word problems, so we need to be comfortable with them. Now, when setting up a proportion, make sure the units are aligned. So we always want units to either be vertically aligned or horizontally aligned. We never want them diagonal. So let's look at our first example. A scale drawing of a new hotel is 15 inches tall. If the scale for the drawing is 1.5 inches equals 10 feet, how tall is the actual hotel? Well, we set up our proportion. We want the inches together. So 15 inches over 1.5 inches. Notice they're vertically aligned. And x over 10 feet. And we know x is going to stand for the height of the new hotel in feet. Using cross products to get 15 times 10 equals 1.5x. So 150 equals 1.5x. So x is 100. Meaning the new hotel is 100 feet tall. Last example, Sheila can drive 58 miles in 45 minutes. How far can she drive in 2 hours? So a proportion, 58 minutes to 45 miles, equals x miles to 120 minutes. Now there's two things you need to notice. One, we converted 120 minutes from the 2 hours. We want to make sure minutes are used for both. And notice that the units, instead of horizontally aligned, or instead of vertically aligned, are horizontally aligned. So miles and miles are both on top, minutes are both on the bottom. This is the opposite of the first one we looked at. Cross products to solve 58 times 120 equals 45 times x. Solve and simplifying x is 154.3 repeated, meaning Sheila can drive 154 2/3 miles in 2 hours. If anything doesn't make sense, please write it down, bring it into class, and we will go over it. Thank you for watching, and that's the end of proportions.